All right, perfect. Hello, thank you all for coming. My name is Eric Cal. I work at VMware, and I currently have the pleasure of serving as Congress Project Team Lead. Today, I'm here to give you a quick project overview and update. Now, first, what is Congress? Right. Let's start with a modern data center. A cloud data center has a number of controllers and services. You have compute, networking, storage, identity, and many more. Each of these services comes with its own set of behaviors, controlled by configuration, by API, and sometimes by its own specialized policy. The result is that it is increasingly difficult and complex to manage the overall behavior of the data center, of the cloud. For example, it's not obvious how to declare and enforce a policy that concerns multiple different services. Say a policy that servers attached to sensitive storage must have strict networking isolation. And here's where Congress comes in. Congress is an open and unified policy framework for managing the cloud. It provides this unified policy layer over all the controllers and services to greatly simplify cloud management and governance. Now, how does Congress do this? Here's a closer look at high-level architecture. A Congress driver for each service exposes its state as tables. Now, the overall state of the whole cloud is then just a collection of all the tables from all the services. So it's kind of like a database now. The operator then declares Congress policies in a domain-agnostic language, kind of similar to SQL, and defining what compliance states must satisfy. The Congress service then continuously interacts with the individual services to enforce and monitor these declared policies. The result is this unified policy framework that can be applied to any combination of services and domains. So there are many official drivers already a part of Congress, and many more on the way. It is also pretty straightforward to add additional services through custom drivers. Now, currently, Congress provides three main capabilities in the cloud management and governance. First, Congress can identify and report policy violations. Second, Congress can react according to action rules in order to correct policy violations. And third, Congress also provides a facility to help controllers anticipate and prevent violations from occurring in the first place. Now let's talk about some of our recent work. A core focus in Congress is to address concrete user needs. And here are just some of the things we've done recently. We added support for a tag-based network security use case with enhancements to Nova and Neutron integration. We also added support for validating config files according to rich constraints. This piece of work was prototyped at Orange to catch incompatible or improper configurations across different services. Integration with Mistral workflow service is also a very key step because it enables Congress to trigger robust workflows. Anything from something as simple as sending an email to arbitrarily complex Ansible playbooks, according to Congress policy. We also added a library of prepackaged policies along with a UI for exploring and activating them. Now let's talk about a couple of these features in more detail. First, let's look at tag-based policy. In a dynamic cloud environment, we often want security policy to apply to workloads based on the nature of each workflow. Production, is it dev, is it a web server, etc. Now, Congress supports this use case by automatically attaching Neutron security groups to VMs based on Nova VM tags. And with the flexibility of the Congress framework, we can also condition policies on all sorts of other metadata, such as owner, role, image, flavor, topology, and so on, not just the tag itself. But that's a good place to start as an example. Here's a sketch of the data flow. Congress will obtain data from Nova and Neutron through the APIs. This is the information about tags, information about security groups, and all the other related information about your cloud. Congress then evaluates the tag-based security policy in relation to the data obtained and determines what changes are needed. Finally, Congress will set the security groups via Neutron API. Now let's see a quick demo of this. Let me switch over. Presenter view. Oops. Did not. Okay. All right, this is good. Okay, so let's first look at this demo setup. So I'm going to have to look over this way. So we have this demo setup, and to start with, we see that the first step is to navigate over to Congress. Let's look at admin policy. That's where you find Congress. And looking at the library. This is, let's log in here. This is the policy library I mentioned earlier, which is a repository for useful policies that operators and people can go look at, explore, modify, build upon, and use, of course. And now the first step is to find this tag-based network security zone policy. The details are in here, but we won't go through that right now. Now, for right now, let's simply activate it. Make sure I activate right one. Okay. Now, let's go back and look at the compute instances in this project. We see that we have one compute instance called demo1, and looking around at it, it currently has no security groups attached to it. Going over to our console, let's see. Going over to our console, let's take a look and see that it currently also doesn't have any tags associated with it. So what we're going to do right now is we're going to add a tag to designate what kind of workload it is, and let Congress policy attach the appropriate Neutron security group. So let's add demo1. Let's say designate it as a production zone workload. And okay, has been accepted. Just to check, if we list it again, okay, we've added a Nova tag. So now what Congress will do is it will receive the information from Nova. It will look at the policy and determine that, oh, we need to set the Neutron security group according to the tag. And let's go back to see if it has been done. So looking at the instances again, demo1. And indeed, we find that a production zone security group has been set. Okay, and this is just a very simple example. Of course, it can be a lot more flexible. Now, let's go back to the presentation. All right. Okay, so continuing with this theme of supporting user needs, here are some features we can look forward to. To support latency-sensitive use cases, such as fault recovery, we're working on integration to act on alarm notifications from Alaska monitoring service and VidCharge root cause service. We're also working on integration with Magnum service for container orchestration and designate service for DNS. Now, most importantly, we want to support your use case. So do reach out to us to explore how Congress can meet your cloud management needs. Now let's look a little more detail at the Monasca integration. So Monasca is a robust and scalable monitoring service that's quite popular with OpenStack operators. When Monasca's monitoring capability is combined with Congress's versatile policy framework, it can solve some important fault tolerance use cases. Here's a very simplified example. Let's say we have a critical workload. We want to monitor the host for any problems, such as packet loss or low disk, and evacuate that workload to a different host at the first sign of trouble. Monasca provides the monitoring, and Congress provides the response depending on the severity of the problems, the importance of the workload, and the physical configurations, and really any other piece of information about the state of your cloud. The integration has already been prototyped at NEC and is being upstreamed. A little more detail on how this works. Again, so in this case, we have Monasca agents on each individual host, sending metrics about the host to Monasca Engine. Monasca Engine then evaluates these metrics according to alarms and notifies Congress of any problems. Congress then combines this alarm information with a broader context about the data center from all the other services and decides the appropriate response according to operator policy. And finally, Congress, once it's determined the proper reactions, it triggers these remedial actions via the API. In this case, it would send a Nova API to evacuate a VM. And now that was just one of the many fault tolerance or self-healing use cases operators are interested in. If you have any interest in this space, do consider coming to the BOF session on Thursday, where we talk much more about self-healing and fault tolerance. We have more than 10 projects working together to understand and address operator needs in the self-healing space. And the most important ingredient is to have operators share their pain points and their requirements, and also everyone with their ideas on how this can be done and how the projects can work together to make things better. Okay. As mentioned before, all of us in the Congress community are really eager to hear feedback. And if you have a thought about how you might want to use Congress, we would love to work with you to make it happen. You can reach us on the mailing list or contact me directly. And finally, let's answer any questions you may have. I've also put my contact info and the information about the self-healing BOF up there on the screen again, just in case someone missed it. Thank you. Yes, please.
Is there any production use case for Congress?
Is there any production case with Congress? I think at the moment we have different companies that have what do you call that? That have a lot of internal use, but as far as external use, we're not aware of that right now. But we are working with some companies who are working toward that. Companies like ZTE and NEC and Orange, for example, are all interested and involved. And yes. And let me just put up some other recent development on the screen, just in case that's interesting. Okay.
I have another question.
Yes, please.
For the demo you showed just now,
Yes.
does that mean the Congress will query other services API periodically to check the policy?
Yes. So there's two modes where Congress obtains information from the services. One is a periodic API call, and the other one is a push notification. That's for anything that's either infrequent or is very time sensitive. We want this right away. You don't want to wait till the next poll. There is that mechanism as well. And so some services Congress talks to via the polling, and some services will push updates directly to Congress.
If there are too many policies defined, will that cause to the performance issues to other services? Maybe, for example, if there are 100, 200 policies
Right.
which relate to Nova, so in Congress you will, for every period, you will call 100 or 200 times.
Great question. So one important point of how this is done, is that the number of API calls Congress makes to obtain information and data is not related to how many policies there are. Congress will make the same number of API calls to obtain a state of the data center and represent it in terms of tables. And all the policies, whether you have 1 or 10 or 10,000, will evaluate on that same state on Congress's internal database. So, yes, please. Thank you. Okay. Okay, so if there are no other questions, and then I think we can wrap it up. Thank you again very much.